Well, you saw how easy it is to graph a circle if it's in the right form, so let's try and put it in standard form by completing the square. So we're going to follow the same steps we had for completing the square. We're going to move the constant to the other side of the equation. Now we're going to group both our x's and our y's. For these problems, we won't have any leading coefficients, so we won't have to worry about that. And then inside the parentheses, we're going to try and write without the exponent so that we can have that on the outside and take half the coefficient of the non-squared variable and then write that exponent 2 outside. We're going to keep the balance. We're going to square what we have in the inside and add it to the other side of the equation. And we're going to do that for both variables. So our center will be found, HK, and we want to make sure that the equation is equal to 1. Now this is not necessary for circles, but it is necessary for the next two things we're going to graph, which are ellipses and hyperbolas. So I figured we'd just do the exact same thing for all three equations, and then we won't have to learn anything new. So this idea of making it equal 1 is just what I would like you to do. So our constant number is 20. We need to move that to the other side. So we have x squared plus y squared minus 4x plus 10y is equal to negative 20. Our next step is to group our x's and our y's, so we need to write those side by side. X squared minus 4x and also y squared plus 10y is equal to negative 20. So I can group my x's by just putting parentheses around those. It'll be very important to make sure that this is always a plus sign when you do this grouping. If it's not, for like your hyperbolas, then you'll want to factor out the negative. And now I'm ready to try and complete the square. I'll write down my x, subtract, and now we want half of this number, and half of 4 is 2. And the exponent's on the outside, plus y, bring down the plus sign, and we want half of this number. Half of 10 is 5, and the exponent on the outside is no longer equal to negative 20. And the reason why it's no longer equal to is because 5 is now in this problem and it didn't used to be. Actually, it's 5 squared. And 5 squared times 1 is 25. So we need to add 25 to the other side of the equation, as well as negative 2 squared is positive 4 times 1 is positive 4. So you have to remember to make sure that you balance your equation and make it really true. So we have x minus 2, the quantity squared, plus y plus 5, the quantity squared, is equal to negative 20 plus 25 is 5, and 4 is 9. Now what I'd like you to do, every time you have an x squared and a y squared, is to make sure that the equation is equal to 1. So we're going to put this number down here. So you can see from this we would start at our center, positive 2, negative 5, and then we'd go 3 in each direction. But I'm wanting you to write the equation as x minus 2, the quantity squared, plus y plus 5, the quantity squared, equals 1, where both of these are being divided by 9. And that'll be because in the x direction I will go 3, and in the y direction I will go 3. And this is the same approach I'll take for both the ellipse and the hyperbola.